Chapter 1, Section 5, Fine-Tuning. In this section here, we'll review the ability to modify our 3D rendering either by changing our density range, color range, as well as our opacity. In the upper right hand corner of the EZ3D software is an icon identified as Fine-Tuning. Simply left click on the option and then from the drop down menu left click on Coloring. This will then open a scale at the very bottom of our window, which will allow us then to perform those three functions, either changing our density range, the color range as we see here, as well as modifying opacity or increasing our transparency of our anatomy. When opening a 3D scan for the first time, it's not uncommon for the soft tissue to superimpose the hard tissue. So what we're going to perform is a fine-tune to segment out our soft tissue. To perform this, we'll navigate the mouse to our fine-tuning icon, left click, and then left click again on Coloring. From here, a scale appears at the bottom of our window. You'll note the orange numbers along the bottom of our scale, such as negative 1900, positive 1900, 3800, and so forth. Referring to the Dr. Hounsfield scale as a reference, where distilled water at room temperature would be 0, that would then indicate that any density greater than the density water will have a positive number. Any density less than the density water will then have a negative number. In this case here, air has a value of negative 1000. The cortical bone typically 1000 and higher. Enamel of the teeth about 2000, metal 3000, and so forth. The white numbers here identify our density range that we've selected. In this case here, the number that says 450 identifies the low end of my density scale, indicating to the software to basically segment out any density less than that value itself. There's also an upper end as indicated by this number right here, indicating to the software to set the upper limit as far as the density to view, as in this case here, 5634. If I wish to change this density range, the simplest way to do it would be to simply position the mouse on top of this purple area, left click, and then slide the mouse to the left. In this case here, you'll note that I've added more soft tissue to my view here. At this point in time, I've set the value to negative 544, which is less than the density of skin or the soft tissue, which is what I'm seeing, but now down to the equivalency of air. As I left click and go further, now I'm getting out to the point where I've gone beyond the density of air, and if I right click, you now see this is my data itself. And then what I'm going to do here is basically use these segmentation tools to segment out based on density. By left clicking and then sliding to the right instead, I've now filtered out my air again, continue going to the right, and then filtering out my soft tissue and separating it out as far as my hard tissue. Cortical bone typically starts right around 1300 or 1200 or so. If I left click and continue to the right, as this value gets higher, I begin segmenting out any density below this number here, roughly 3100. Left click and slide to the right or left until you have your desired density range established, and then from here we'll move on as far as establishing our color range. Now the whole purpose behind having color applied to our 3D rendering is due to the fact that we are trying to view a three-dimensional object, which is the human anatomy here, on a two-dimensional surface, which is our computer screen. By adding color helps create a sense of depth. The color that we add is controlled by the angle of this line right here. The basic concept is the more vertical this line is, the less color we have. The more shallow the angle of this line is, the more color we'll have. As an example of that, I'll position the mouse at the top of this box here. I'll left click, slide it to the left until it's vertical. I've now indicated to the software that any density above this number, I want it to be white. If I want to apply color, however, create a sense of depth, I'll left click and slide to the right. Now I've added more color to my view here, again enhancing the sense of depth of this 3D anatomy. This becomes more subjective, so feel free to utilize this tool until you find a color range that you feel is appealing. The last function that we have is the ability to adjust our transparency, or being able to see past the cortical plate to be able to see the outline of our roots. To do that, we'll position the mouse where it's shaped like a triangle, move it down on top of this horizontal line where it changes into an arrow going up and down. I then left click, slide it down towards the base, and then let go of my mouse again, which is now generating a transparent view of our anatomy. However, it may appear somewhat washed out, so this is where we have the ability where we can kind of fine-tune our view. I'm going to left click on this box here as far as our color range. I'll add more color here. Perhaps go down a little further as far as my density range. And once I've selected the proper view as far as segmenting out my density, color, and opacity, what I have the ability to do is save these values with what we call an opacity preset. This is where the menu over here comes into play. When I left click on save, this is where I can assign a name for this. Perhaps call this ortho view. Left click on save, and now I have saved this opacity preset to my opacity library. To retrieve it, continue up the menu here and left click on load. Left click on the scroll bar, and here is the opacity preset that was just saved. I have the ability through these series of opacities here to either choose one and apply it either on a per patient basis, or placing a check mark here for default opacity, and each time the scan is open on this computer, it'll then apply these values to that scan as well. So at this time, I would encourage you to pause the video once again and go to the 3D software to replicate the steps of the fine-tuning function to segment out based on density, color, as well as opacity.